in the one. Come on, you sing. When I see that cross, I see freedom. When I see that grave, I see Jesus. And from death to life, I will sing your praise. In the waters around. When I see that cross, I see freedom. When I see that grave, I see Jesus. And from death to life, I will sing your praise. In the waters.
Morning, Nick.
Good morning. My Savior's God, victorious. My chains are gone, my debt is paid. From death to life, and grace to grace. Good morning, everybody. Welcome to another week of classes. I hope that all of you are doing good. I'm just gonna give maybe one more minute to see if anybody else will be joining our session today, and then we're gonna get started, okay? I did send a message in the Google Classroom that I would like you guys to have your scientific calculators or a regular calculator. I think can work for today, but scientific calculator. So if you haven't gotten it, please go ahead and find one before we actually get started, okay?
Morning, Miss.
Good morning. So I'm just giving one more minute for anybody else that will be joining us to join us today. And then we will get started, okay? You need your calculators. Okay, guys, so we are starting, not starting, we're continuing this week with our unit entitled Shaping Our Faith in God. And as we continue in this unit, we continue talking about geometry and different aspects of geometry, which is a really, really big unit for us to cover. So now this week, if you guys have taken a look at the content and even at the activities that I have posted in Google Classroom, you would have realized that we're moving a little bit away from the what we've actually been doing, which is the graphing, and then now we're moving more into shapes and what shapes have to offer and the calculations that we get to perform when it comes to using these shapes. Right? So let's continue. And my deep hole for this unit, as you guys would have already, maybe have know what I'm gonna say when I mention my deep hope every week. And if you guys had taken a look at the video that I made for the teachers' celebration of learning, um, I decided to select some of your works that I thought were one of the best. I couldn't include everybody's work, even though I wanted to put as many as them as I could, but um, if you guys saw the video that I created, that video basically talked about my deep hope and what it is that we have been accomplishing for the past weeks and what we want to accomplish for the rest of this unit. So now, as we continue with the deep hope, I would like you guys to be God worshippers. And you guys have been practicing that being when you're doing your, especially the formative activity that targets the biblical aspect of this unit, being God worshippers and being image reflectors as we understand these through lines through the CFRR. And doing all of this by courageously designing all of the assignments that I have been grading and collecting so far entail hands-on work because geometry is a lot of hands-on. And even though this week is not going to be that much of hands-on, you're still going to have that activity and that practice in this week where you have to be making things with your hand. um, and then when we recall our biblical integration, we are forming this geometry unit, shaping our faith in God around the idea of being caretakers of creation. And both of the formative activities that you guys have been done already talked about being um, take caretakers of creation. If you remember the first activity that you guys did with the star, and I know that a lot of you did not perform well on that one because you submitted an incomplete assignment. The star included you guys to find a Bible verse and to include the Bible verse that talked about being a creation take care caretaker. And then the activity that you guys did after that with the geometric tools, where you use tools for construction but God uses you as a tool for creation care. All of these are built around the idea of being a caretaker of creation. And even your formative activity for this week includes that as well. And the essential questions for this unit. And then as we move along, we are understanding how geometric properties are used to help solve real world problems. And this is what we're targeting this week specifically with the ideas and the topics that we're talking about this week. And then now, how can geometry be used to solve real world situations? And we have done already 3 weeks of this unit, and this is our fourth week. We have 2 more weeks to go after this for us to finish off this unit of geometry. And then now, this week, what we are covering are basically 3D shapes. Finding volume and surface area of 3D shapes, and knowing the difference between these 3D shapes, and knowing the properties of each of these shapes. So now today's lesson, I want to start off with our first activity. And I would like you guys, and you could use the chat, all of you to tell me what a 3D shape is. In your own words, what is a 3D shape? What is a three-dimensional shape? In the chat, I would like all of you to put something in the chat. What is a 3D shape? And I'm pretty sure you guys know what. Okay, let's start off by asking this question. Do you know what a 3D shape is? Yes or no? Put that answer in the chat. Yes or no? Everybody put yes or no. And if you don't know what it is, that's completely fine. Okay, you know what it is. So now tell me what a 3D shape is. Or do you know what it looks like? Are you telling me that you know what it looks like but you don't know how to define it? Is that the problem? Because that's the problem with a lot of students. Don't be shy if that's the problem that you're having. I can see, okay, this is a 3D shape, this is a 3D shape, but I don't know what the correct meaning for a 3D shape is. Is that the issue? Because if you guys can't tell me what a 3D shape is, you're telling me yes, you know what it is, but you don't know how to define it. Okay, I see a shape with a length, a depth, and a width. Very good. That's a very good definition. Um, Definition that might apply more for certain 3D shapes, but very good. It's shapes containing three dimensions. Very good. That's why we call it three-dimensional shapes. It's in the name. But let's take a look at what the definition is. A three-dimensional shape, or 3D, we call it 3D, or a solid, is a shape that has a length, a breadth, and a height. And those are the correct words. And in the brackets, it's the depth and the width, the one that I saw that Johan included in chat. So it's made up of faces, of edges, of corners, and planes of symmetry. So when we talk about a 3D shape, and the most common 3D shape that everybody knows, it's a cube. I know a cube is a 3D shape. If I would have asked you guys to name examples of 3D shapes, more likely a lot of you would have put a cube because you're very familiar with what a cube is. And we know that a cube is a 3D shape. So whenever they ask you for a definition for a 3D shape, it is a solid shape that has a depth, a width, and a height. A depth, a width, and a height. All right, because length and depth mean the exact same thing. Breadth and width mean the exact same thing. So it's a length, a width, and a height if we're using simpler words, right? Length, width, and the height. And it is made up of three things: of surfaces, of edges, and vertices. And we're going to look at these things because when you guys do your first assignment, you have to be able to identify these. So now there are so many 3D shapes that we could talk about. We're only going to be working with basics ones. Um, we're going to be working with spheres and cylinders. And that includes spheres, cylinders, and cones. All of those three are included in under one branch because they include parts of formulas of circles. And you have prisms. Prisms would be like a cube, a cuboid, a hexagonal prism. And then we're going to talk about pyramids. So these are the three branches of 3D shapes that we're going to be looking at. Of spheres and cylinders, and under spheres and cylinders we have the sphere, the cylinder, and the cone. Under prisms we have the cube, the cuboid, the and other different prism, triangular prism, all of these prisms that fall under that branch. And then we have pyramids, where you have a square base pyramid, a triangular base pyramid, different types of pyramids. And these are the three branches that we're going to be looking at in this week. So now, what are vertices, faces, and edges? And we have to be able to identify the difference of these. If you guys were to have gotten a table, and in the table it has Cube, cuboid, sphere, and triangular prism, hexagonal prism, triangular pyramid, all of these 3D shapes listed, and it has vertices, faces, and edges. You need to be able to tell me how many vertices does a cube have? How many vertices does a triangular prism have? How many faces does a cuboid have? How many edges does a cone have? All of these things. So take a look at the diagram that I have there, and you will be able to see that vertices are corners, all the little corners. So if you're taking a look at this cube, how many vertices does this cube have? How many vertices does this cube have?
8 minutes.
8. Very good, Sitlali. 8. How many faces does this cube have?
6.
6 faces. Very good. And how many edges? Edges are the lines. How many lines make up this shape? How many
12.
edges? How many?
12.
12. Very good, Esner. So, when they tell you, give me the properties of a cube, you are going to say it has 8 vertices, 6 faces, 12 edges. These are the properties of this cube. Everybody understands? Yes? No? Maybe?
Yes, miss.
Good. So, if you guys would take a let me go to the let's do this practice activity, and then I will talk about the this one. Okay, can you guys see that?
Yes.
Yes, miss.
Okay. So this is level 1, basics. How many faces does a cube have? We just responded to this one. Anybody?
6. 6.
6? Okay. How many edges does a cube have? What are edges? How many?
8, miss.
Edges are the lines. How many
12.
lines?
12.
12.
12. Very good. And how many vertices?
8 minutes.
8. Very good. Now look at this shape. It's a triangular prism. How many vertices does this triangular prism have? How many little
6.
corners? How many?
6.
6, miss.
6. Very good. How many edges does it have? How many lines make up this shape?
9 minutes.
9? We have 1,
Yes.
2, 3 on this side, 4, 5, 1 at the back, 6, and then another 3 on the end. That gives us 9. Very good. How many faces does a tetrahedron have? This shape over here.
4, miss.
4 minutes.
4. Very good. How many faces does a square base pyramid have? There is no drawing, so imagine a square base pyramid. A pyramid that has a square at the bottom. How many faces does it have?
5 minutes.
5. Very good. How many vertices does a square base pyramid have? How many little corners does it have?
5 minutes.
5. How many edges does a hexagonal prism have? This one is a tricky one. Hexagonal prism. Remember what a prism is? This is a prism.
18.
How many?
15.
18?
18.
18? Let's put 18 and see what happens. How many faces does a pentagonal prism have? Pentagonal is 5 sides, right? Hexagonal is 6 sides. So, how many faces does a pentagonal prism have?
Four
Prism.
times.
How many?
Six.
My uncle is more.
6 or 7?
Six, miss.
Are you sure? 6 or 7. Anybody else? Anybody has a second opinion? 6 or 7. Hexagonal prism. I mean pentagonal prism, sorry. Pentagonal prism. Use your imagination. A pentagonal has 5 sides. So if this is a prism, it has to have a pentagon on one side and a pentagon on the other side, and then it is covered all around. Right? So how many sides does a
Seven.
pentagonal have?
7, miss.
Seven, miss. Seven. Seriously, seven.
7. Okay, 7. And let's check it. 9 out of 10. So let's see where we got it wrong. Over here, how many edges does a tetrahedron have? Edges. Okay, let's move on to level 2. Let's see if we can. Okay, we're not gonna do this because this is Euler's formula. So, anybody has any questions before I move on?
Miss, para lo que dijo, creo que tiene 6 edges. 6.
6 edges. Okay. No more questions, guys? Anybody has any?
No, miss.
Okay. Okay.
No, miss.
So let's continue. Let me go back to the PowerPoint. So now we're gonna talk about the sphere. I'm gonna talk about the sphere in depth because the sphere is one of the shapes that we're targeting. There are so many 3D shapes, guys, and I wish that we could take our time and look at all of them and practice questions using all of them, but we don't have the time to do that. So I'm gonna concentrate on the sphere because the sphere is one that might give some students a little bit of difficulty understanding, especially if you guys don't remember the formulas for area and the circumference of a circle. So before I even start with the sphere, this 2D shape is a circle. What is the formula for area of a circle? Anybody knows?
Pi, miss.
But it uses pi. Yes, I know it uses pi, but what is the
Pi
formula?
r square, miss.
Okay. Tell me what
Circumference.
that means though.
Circumference. Algo así, miss.
The f-
Miss, area equals pi times radius square.
Very good. Area is equal to pi times radius square. Now, what is the formula for circumference of a circle?
Miss, it doesn't 2 times pi times radius.
Okay, that's
How
one
about you?
way. That's one way of writing the formula. Very good. 2 times pi times radius. What is another way of writing circumference? Guys, remember when you were back in first form and you were doing area and perimeter and all of these things? And don't say you didn't do it because most of you were in first time when I was teaching first form and when Mr. Cantun was teaching first form. And you guys should know this. So what is the formula for circumference of a circle? I already got one of them. What is the other one? Think, guys, think.
Miss, which one was said?
The one that was said was 2 times pi times radius.
The other one is on 3.14.
You are 3.14 is pi. That is what pi means, right? And we're gonna be using 3.142. I want the formula. I don't want what pi represents. Yes, I heard somebody said miss. Nobody?
Pi times diameter, miss.
Pi times diameter. Very good. Why is two okay? Why do we have two different formulas? Why does one formula say 2 pi radius and the other formula say pi times diameter?
Because the radius is just half of the circle.
The radius is half of the circle? I think you know what you want to say, but you didn't say it in the correct way. The radius is not half of the circle.
It's at the center of the circle.
At the center of the circle, we have the center of the circle. Think, guys, think. On your notebooks, draw a circle and tell me. I am showing what is in the middle of the circle. We have the center. You see the radius. You see the diameter labeled there. Why does one formula say 2 pi radius and the other one says pi diameter? Why?
One is finding the half of the circle, miss. Something like that, I think, and the diameter is finding the out of the circle, I think.
Mm, I don't think you
I
guys.
Miss,
Yes.
Miss, isn't the diameter the height or of the circle, and the radius is the measurement of the center? I think.
No, I did not think that I have to go over the basics with you guys, and luckily I did, because when we go to volume and surface area and I tell you this is the diameter, this is the radius, this is what you're going to be using to find all of the let me open a Jamboard. Let me open a Jamboard and then we will you guys will see me writing what I have to write here. When did I leave my Okay. Okay, give me 1 second, guys. I will quickly open a Jamboard, okay? New Jamboard.
Miss, yes, ahora sí, yes.
Okay, tell me.
The radius is half the diameter, and the diameter is twice the length of the radius.
Okay, very good. Let me share this tab instead. Okay, can you guys see the Jamboard? Let me get my tablet right now, guys. Because I don't have it in this one, I think. No, I don't have it. 1 second.
Estaba un poco cerca, pero
Okay, guys. Okay. So, when we are talking about this, let me draw a circle over here. Okay, the circle. This circle, what do we call the line that forms a circle? First question, what do we call that? Anybody?
The diameters.
No, it's not the diameter.
Circumference.
The circumference, very good. The circumference. Okay. What do we call the point in the middle of a circle?
The
Center.
radius.
What do we call it?
The radius.
No, it's not the radius.
The center of the circle.
The
The
Center.
center.
center of the circle. Very good. The center of the circle. Okay. So we call this circumference. All right. Then we have the center of the circle over there. And we call this the center. Good. Now, if I draw a line from the center to the circumference, what do we call that?
The radius.
The radius. Very good. Radius. If I draw a line from circumference to circumference that passes through the center, what do we call that line?
The diameter.
Okay, sorry about that. The diameter, very good. The diameter. Good. Everybody understands this. Yes?
Yes, yes.
So now the formula for area, as you guys mentioned, is pi radius squared. The formula for circumference, we have 2 pi radius, or you had pi diameter. And my question was, why does one formula have 2 radius and the other one has diameter? And that was what Sitlali answered. That when we look at this diagram, 2 of this make 1 of this. So whenever we write the formula and we're going to use radius, I have to make sure that I'm talking about 2 radius. If I'm using diameter, I have to make sure that I'm talking about the diameter. Everybody has that clear? Yes?
Yes, miss.
Okay. Okay. Let's move on to another 2D shape. What do we call this shape?
Rectangle.
Rectangle, very good. What makes up a rectangle?
The length and its width.
Length and width, very good. Which side is the length?
The largest one and
The
the width.
largest one and
So is it the top, the bottom, the right, the left?
The top.
Okay. This is the length. What else?
And the bottom is
The bottom, very good. What do we call the ones on the side?
Wait, miss.
Width, very good. What is the formula for area?
Length times width.
Length times width. And what is the formula for perimeter?
Length
Length
times
plus
width
width.
times height.
Ooh, one person, repeat again.
Length times width times height.
Length times width times side. That's what you said?
Height.
Times height. This?
Miss Trayana height, miss.
That's what I was going to ask. Where did you guys get height from?
Height times base.
Era is length times width, miss.
But length times width is area.
Miss length plus width plus length plus width.
I feel like I'm teaching first form right now with you
Height times
guys.
base. No, es miss. Height times base.
Where are you getting height and where are you getting base?
Miss, what was the question, Miss?
What?
Miss, yo te estoy hablando, si eso es lo que usted me dio.
Perimeter is equal to length plus width plus length plus width. That is what Sitlali said. I didn't say it's wrong, it's correct, but that's not the formula a third farmer is supposed to be using. Let me put it that way.
Perimeter
Length
equal to
square.
length plus
Width
width, Miss.
square.
Okay,
Miss,
perimeter is equal to 2 length plus 2 width. Okay, that works. But still not the one you guys should be using.
Length square and width square.
miss. The
Yes.
perimeter equals 2 times close bracket length plus width plus close bracket.
Okay, very good. Very good. These are the formula, perimeter, and area. Questions? Questions? No questions? Next shape. What is that?
Square, miss.
Okay, square. Label the square. What do we call it?
Length times width, Miss. No, size times size, Miss.
What is side times side?
The formula, miss.
The formula for what?
For a square,
But for what of the square?
Area, miss.
Okay, tell me area is equal to side times side. But that's not the formula you guys should be using. You guys are like more sophisticated. Think about the formula that you should be using for area of a square.
Side and 4.
For area?
Miss A equals square 2. No, side. It's side 2. Okay.
This, guys, this. Side squared. And then for perimeter, I heard someone say the formula. It is 4 times side. Because all of these sides measure exactly the same. Yes?
Yes, sir.
Questions? Questions? No questions?
No, miss.
Okay, let's get into the actual topic that I'm supposed to be teaching today, reviewing this. Let's talk about Let me share my screen here first because I'm looking at the time. You have sphere. Please read what the sphere says. These are the pyramids that we're going to be talking about: square base, triangular base, hexagonal, pentagonal. You have pyramids, then you have prisms, and these are the square prisms. So we're talking about a cuboid and a cube, triangular prisms, pentagonal prisms. We have hexagonal prism. We have so many prisms. And then we want to talk about volume. What are the formulas of volume for these shapes? So we talked about 2D shapes right now because I want to review. You guys have to know what is the radius, what is the diameter, what is the height, what is the base, what are these things. And I didn't do the triangle, and I think I should have done the triangle because the one was one of the important ones. So we're talking about volume, and I had questions here for us to do. I'm looking at the time. We don't have time to do that. So tomorrow we're gonna start off with these. I need you guys to have your calculators tomorrow, and I want you guys to take a look at the content for this week. I am going to be posting another document on Google Classroom today that has the formulas that we're gonna be using. Please have those formulas for our class tomorrow. Everybody understands that?
Yes, miss.
So before the time is up, I'm gonna do the last shape, the 2D shape, because I want to review this one. What do you call this shape?
Triangle.
Triangle. Triangle.
What are the parts of the triangle?
Length times heightness.
Woo! No. What are let's label the triangle first.
Base and
What does
height.
the triangle have?
A height, miss,
A height,
and a
very
base.
good.
Base.
This is the height, and it has a base. Okay.
Vertex angle.
We're not talking about angles. We're not talking about angles. We
It,
move
it isn't base times height.
incomplete formula.
Base times height over 2.
Okay. Base times height over 2, or half base times height.
Miss, pero más usan ese uno, area, el equal, el half times base times height hoy en día que el base times height over 2.
Yeah. This one. Both of them are the same thing. It's like if I did the 1 times the base times the height, it gave me this one. But this is the correct formula to be using. Now the formula for perimeter. Guys, formula for perimeter. Nobody knows?
A plus B plus C.
Very good. Perimeter A plus B plus C. Where did that
Plus
formula
C.
come from? How did we get that formula?
Miss by the sides.
You add the 3 sides. Very good. One side is A, the other side is B, and the other side is C, and we added the 3 sides and we get the perimeter. Whew, okay, guys. That will be it for today. We have a lot to work on. Please, please, please have your calculators for tomorrow. Have the formulas for tomorrow. If you have taken a look at activity number 2, that is only problem solving, and I already know that it's going to take us some time to do. Right? Questions? No questions? Questions, guys?
Yes.
Okay, you guys are free to leave. Enjoy your rest of the day. I will see you guys tomorrow.